We're going to look at relations, okay? And relations is just a set of ordered pairs. There's usually some rule that tells us how we can get from like the x value to the y value. But the things that we're going to be concerned about today is domain and range. So the set of x values, meaning in my relation, every single x value that is possible, that is called the domain. All right. And then the set of y values is called the range. Okay. So that's all of the possible y values. Okay. So when we have a list of ordered pairs, domain is the list of all the x values. And we're going to put it in like this little funny bracket looking thing here. I'm not the best at drawing it, so something like that. All right, and then all the possible x values are -3, -2, 1, 3, and then -3 again. I don't need to write it twice, okay? If a number appears more than once, we don't have to write it twice. And range is all the y values. So again, I'm going to make my little bracket, all right? I have 1, 0, 2, -4, and 5, and then I'm going to make my bracket again. Typically, sometimes, a lot of times, you'll see this rearrange into number order. So like I would start with -4 and then go 0, 1, 2, 5. All right. We just write them in order from least to greatest. Okay. Different ways that we can represent a relation. We can have a list of ordered pairs. We can have a table. We can have a mapping, and we can have a graph. Okay. So table, simple, easy. You've seen it before. All right. -3, 1. -2, 0, 1, 2, 3, -4, and -3, 5. All right. In a mapping, we have all of our x values over here. So -3, -2, 1, and 3. And then we have all of our y values in a second circle. So -4, 0, 1, 2, 5. And then we draw arrows to show which numbers are linked together. So -3 goes with 1. All right, -2 goes with 0. 1 goes with 2. 3 goes with -4. And then -3 also goes with +5. So we would have 2 arrows coming out of it. Okay, and then for graphing, we're just going to graph those ordered pairs. So -3, 1, I'm going to go over 3 up 1, that's 1 point. All right, -2, 0 would be right there. 1, 2 would go right there. 3, -4 would be right there. And then -3, 5 would go all the way up here. All right, and that would be the graph of my relation. Okay, so I want you to pause here and try number 2. Fill out the domain and range and then all the different ways that we can represent the function. All right, so your answer should look something like this. Okay, now this third one we're going to look at. Okay, we're going to take the domain and range from our ordered pairs. Okay, so what I'm going to do just to make it easy to organize, I'm going to change this graph into a table first. So this point right here, I'm going to count each pair. All right, so this point right here is -5, -4. All right, this one here is -2, 3. This one is 0, -3. This one here is 2, -5. And then the last one out here is 4, 2. Okay, and so now I can write my domain and range just like I did before. All right, so -5, -2, 0, 2, 4. All right, and then let's see, -5, -4, -3, 2, 3. Okay, now this is what we call a discrete relation because it has specific points. It can only be those points. It can't be anything in between. All right, but we also need to be able to write domain and range in what's called continuous functions or relations. So what that would look like is if all of these dots had lines connecting them. Okay, now my domain is not just this point and this specific point. It is all of the points on this line as I travel. Okay, so it doesn't just have to be whole numbers. But it would be impossible for me to list every number between -5 and this one is -2, because I could do like -5, -4.9, -4.8, -4.7, but I could go even further. Like I could go -4.52347889, right? Like there's no way for me to list all of those numbers. So when we do the domain of continuous relations, we say where does it start and where does it stop? Okay, and so domain, the furthest left that this graph goes, all right, is -5. All right. So I'm going to say that -5 is less than or equal to x, which is less than or equal to, and the furthest right it goes is all the way over here at +4. Okay, so my domain has to be somewhere between -5 and +4. Every single decimal that you could possibly think of between -5 and -4, that is my domain. Now for range, all right, we're going to look bottom to top. So the lowest that this graph goes, and then the highest that this graph goes. So the lowest point is -5. All right, and this time it's going to be y because range is y values. And the highest point is +3. Okay, so my domain, if I were to draw in and make this continuous, my domain would be between -5 and +4, and my range would be between -5 and +3. All right, so here we have some more continuous graphs, okay? I'm actually going to start with number 2. So again, domain is left to right. So the furthest left this graph goes is right here. That's the barrier on the left side. And then if I go to the right, the furthest it goes is right there. Okay, so that means my domain goes from, this is -3, all right, and then it goes all the way to +3. Okay, then for range, I want the bottom and the top. So the bottom of this graph is right here. The top of this graph is right there. So this is also -3. Okay, less than or equal to, it's going to be y. And then the top is at +3. Okay, so my domain is -3 to +3, and my range is also -3 to +3. Okay, now if we look at number 1, okay, domain would be left to right. On the left side of this graph, what do we see right here? There's an arrow. That means this graph goes forever to the left. So I can't really draw a barrier, a line, because it keeps going. And on the right side, it's the same thing. Okay, when that happens, we say that the domain is from -infinity, all right, to +infinity. Okay. Another way that, and these like sideways 8s, that's the symbol for infinity. Another way that you could write this is we say this. Okay. Let me clean this up a little bit. All right, this is the math symbol for x is an element of the real numbers. That means x can be anything, right? Because if I'm going from -infinity to +infinity, the arrow means the graph's going to go forever. So it can be literally anything. And this symbol right here, that is the symbol for real numbers. The way I draw it is I just make 2 lines and then draw an R. Okay, so it's an R with 2 lines. All right, the X is a regular X. The E is supposed to be, if you see it printed, it's like curved. Okay, if you just write a capital letter E, I don't know what you're talking about. Okay, so either this or that would be an acceptable way to write domain. Now, if we look at the range, for bottom, this graph does have a low point. It stops right there. It never goes any lower than -2. Okay. And then, but then when I go up, it has arrows. Okay, so that means the graph keeps going up forever. So I would say that y is between -2 and infinity. You might also see this written as y is greater than or equal to -2, because it can be any number that's bigger than -2. Okay, and that is it for 5.1.